Climate may seem like a boring familiar topic in our lives. The cycle of seasons, for example, has probably been one of the most immutable topics you know. And that all happens to be one giant fallacy. As a matter of fact, the Earth's climate is one of the most dynamic systems in history. You most likely know that a mere 20,000 years ago, the Earth's temperature was approximately 10 degrees lower than it is now. An ice sheet almost 3 kilometers thick covered all of Canada. Due to these ice sheets, the sea levels dropped, creating a land bridge that spanned the continents. Plants, animals, and we humans all crossed the land bridge to settle in this wasteland of ice. And that's just the tip of the iceberg.
For the past 800,000 years, the Earth has cycled through freezing ice ages and warm interglacial periods. The latter occurs every 100,000 years. These aforementioned climate variations are known as long-term changes, as they obviously occur over long periods of time. But why do these changes occur? We should shed some light on this, or rather, let the sun do that for you. Differences in how the Earth absorbs or distributes the sun's energy are precisely why long-term changes in climate occur.
For example, take a look at the infamous theory of continental drift and plate tectonics. Imagine if the Earth was but a giant steaming hot pie straight out of the solar ovens. The pie was most definitely in an equally giant pie pan. Pangea, that is. The continents of our delicious Earth pie were, at the moment, in one big continent called Pangea. However, all it takes is one hungry interloper, or some convection currents deep underneath the pie's crust, for the continents to drift apart into the familiar slices we know today, about 225 million years later. As the continents drifted, the steam and filling, wind and ocean currents changed, affecting the heat transfer on Earth. The size of the bodies of water on Earth also changed. The smaller ones in the northern hemisphere resulted in a more severe climate, while the nice big bodies of water located in the southern hemisphere ensured a milder climate.
Even mountains are contributors. As tectonic shifting occurred, new mountains were raised up, such as the Canadian Rockies, and others were eroded down, such as the Appalachians. This also has an effect on regional climate.
But wait! Before you enjoy that continental breakfast, there's more.
The Earth, being the eccentric planet it is, has even more factors affecting long-term climate. In particular, the Earth's eccentricity probably has more to do with it than you expect. Eccentricity is actually the shape of the Earth's orbit around the Sun. It is elliptical at times and circular at others. It's no wonder how this affects climate. The Earth also wobbles and tilts. The exact angle of the Earth's axis pitches from 22.1 degrees to 24.5 degrees. This affects the seasonal distribution of climate, and the Earth's current tilt, incidentally, is at a tipsy 23.5 degrees.
Finally, the Earth's axis also wobbles around in a circle every 26,000 years, called precession. This causes Earth's axis to point in different directions, not unlike a spinning top, or Beyblade. In fact, in 12,000 years, our pole star will ironically not be Polaris, but Vega. I'm sure our big star has no trouble sharing the limelight though. So right about now, our buddy the Earth probably seems pretty esoteric, in a very slow, long-term kind of way. But did you know we can observe climate variations in our own backyards? Welcome to short-term variations in climate. Unlike the enduring long-term variations, short-term climate variations are just that. They occur over a short period of time. Take, for example, volcanic eruptions. Occurring relatively quickly, volcanic eruptions spew tons of dust, rocks, and soot into the sky. All that debris in the atmosphere can reflect the sun's radiation, causing a temporary cooldown.
But if hailing the arrival of volcanic eruption isn't your thing, we can hail something else. Thermohaline, that is. Thermohaline circulation is an oceanic conveyor belt, distributing heat. At the end of the last ice age, the vast quantities of fresh water dumped into the oceans by melting ice sheets disrupted the circulation for a while, also dropping temperatures. But you can't take a breath yet. In fact, air currents also affect short-term climate. Once every 3 to 7 years, the prevailing winds switch direction, changing ocean currents so they push eastward. This is called El Niño.
If you can't stand all these current events, you can observe climate change just by looking straight into the sun. Note, please do not do this. Minute changes in the amount of radiation the sun emits can also have an effect on climate. We just don't exactly know why. So there you have it, both long-term and short-term variations in climate.
If you feel sick of all this climate junk, just ponder how we're lucky to have a stable climate at all. On planets such as Mercury, the non-existent atmosphere ensure alternate blazing heat during the day and freezing cold night, all year round. Now that's just anticlimactic.